Hello, my grade 10 math students. So today we're going to talk about multiplying binomials, and we've talked about this a lot. We've basically talked about how we can multiply something into a set of brackets, and we called this the distributive property. Oops, again, writing with white. And remember that in order to use the distributive property, basically you have to take the first term and multiply it by everything inside of that bracket. So for example, before I go on to these more complex ones, if I had 3x plus 2 here, I would do 3 times x, which is 3x, and then I would do 3 times 2, which is 6, okay? So we're going to use the same idea when we have two brackets side by side. And what we're going to do is we're going to take the first term and multiply it by the second bracket. Okay, so I'm going to take x, my blue x, and I'm going to multiply it by the entirety of the second bracket. So I'm just going to write the second bracket right beside it, like this. And then I'm also going to take the next term in my first bracket, which was plus 2, and I'm going to multiply it by the second bracket again. Okay, and what is this doing? Well, this is making sure that I'm multiplying everything by everything. So again, I'm just taking that first term here, multiplying it by the second bracket, taking that second term, multiplying it by the second bracket. So now let's see how this unfolds. I'm going to take my first term here, my x, right here. I'm going to multiply it by the first thing inside of the bracket. X times x, that gives me x squared. Then I'm going to take my first term again, multiply it by the second thing in the bracket. X times 3, that gives me 3x. Okay. Now I'm going to do the exact same thing with my second bracket. So I'm just going to leave this aside. Let's look at this one. I'm going to do 2 times x. That gives me 2x. And then now I'm going to do 2 times 3. That gives me 6. My next step is going to be collecting like terms. If I look here, there's no other x squared terms. Remember, a like term is something with the exact same variable, exact same exponent. So I have no other x squared terms, no other squared terms here at all. So I'm just going to rewrite x squared. I do have lots of x's though. I have a 3x plus a 2x. Those are like terms. 3 plus 2 is 5. And I have no other numbers, so I'm just going to write that plus 6. Now, I know that this doesn't look like a complete solution because we haven't found what x is, but that's okay. This is how we do this. This is our answer. Okay, so this is math smiley face, complete solution. Okay. So let's try it again with a different example. Again, I'm going to take the things that are in my first bracket, so my 2x and my 3, and I'm going to put them outside of the second bracket. So here I'm going to write my 2x, and now I'm going to rewrite my second bracket, my x minus 2. Then I'm going to write my plus 3 and my x minus 2 again. Okay. So now we're going to do that distributive property, so the rainbow. We're going to take the first thing, multiply it by the first thing. 2x times x, that's going to give me 2x squared. 2x times negative 2, that's going to give me negative 4x. 3 times x, that's going to give me positive 3x. And now 3 times negative 2, that's going to give me negative 6. Okay. I'm going to gather my like terms. I notice that this is the only x squared term I have, so I'm just going to rewrite that. But I do have a couple of bundles of x's here, so I have negative 4x plus 3x. Negative 4 plus 3, that's going to give me negative 1x minus 6. Again, I know that this doesn't look like a typical solution, but this is where we're at, okay? This is all we do. We start with something small that's tightly bundled, and now we're going to end with an expanded version. So this is exciting. Happy math smiley face. So just like in everything in math, there is a couple of different ways that we can do things. So I like personally the first way. I think that it keeps everything super organized, but you can also use what's called FOIL. And I know a lot of your teachers, especially at St. Teresa's, they really love this FOIL method. So I feel like we should definitely talk about it, because next year when you take math, you want to be able to do it more than one way. And you guys get to pick which way you do. So FOIL is a special acronym, and it tells us how to expand the brackets. The first term in FOIL stands for the first term. So you're going to take the first thing in each bracket, multiply it together. So x times x, that's going to give me x squared. Now you're going to take the outer term. So you're going to take the first term in my bracket. Sorry, I'm just trying to color code it for you guys. So you're going to take outer. So you're going to take the first term and multiply it by the outer thing. Okay. So x, goodness gracious, come on tablet, x times 7. Then you're going to take the inner term. So negative 3 times x. And finally, you're going to take the last terms and multiply those together, which is negative 3 times 7, which is negative 21. Okay, now you're going to collect your like terms. I have no other x squared, so I'm going to rewrite that. 7x minus 3x, that leaves me with plus 4x, and I have no other whole number, so I'm going to leave it like that. Okay, same thing again. So I'm going to take my first term, I'm going to do 3x times x. That gives me 3x squared. I'm going to do 3x times 2. That gives me 6x. Negative 5 times x. That gives me negative 5x. Negative 5 times 2. That gives me negative 10. I notice that I have no other x squared terms, so I'm going to rewrite that. I can gather together my x's, so 6x minus 5x, that leaves me positive 1x, and my subtract 10, or my negative 10. And here's my expanded solution. Okay, so these are the two ways that we can expand things. You're going to work on the practice problems that are on our Google Sheet there. Please send me an email if you have any questions, or better yet, type them out in that Google Doc so that we can make sure that we are touching base. I hope everybody is doing super well, and you guys are all definitely very missed.